Now, we have circle C, and we are asked to solve the unknown measurements of the variables x, y, and z. First, we need to understand how do we define or illustrate each of the given variables in order for us to determine an equation based on relationships so that we could solve them later. Variable x here is an angle formed by these two secant segments. This is a secant segment, for it intersects circle C at exactly 2 points here and here. This is also an example of a secant segment because it intersects the same circle at exactly 2 points here and here. Please do not be confused with the term secant segments, because as we already know, secant are lines that intersect the circle at exactly 2 points. But since there is no indication that this is a line, so we just call it secant segment. For y, this is an inscribed angle with the vertex here and the sides, this chord and that chord, even though if it is actually, this chord is part of the second segment here, the second segment actually contain a chord. So we have this as our inscribed angle intercepting this arc here, which measures 58 degrees, and another arc to which we don't know the value. And z is an arc from this point to that point. So let's start with solving the value of x. X, again, is an angle formed outside circle C, and it is an angle formed by two secant segments here and here. For angles formed outside the circle from two secant segments or two intersecting secants, there is a unique relationship as to that. The measurement of angle x, being the angle formed outside by two intersecting secants or secant segments, is actually 1/2 the difference of the two intercepted arcs. Again, 1/2 the difference of the two intercepted arcs. What are the arcs that are intercepted by angle x? The first one is this arc here. This one is 58 degrees. And the other arc is on the other endpoints of the second segments, this arc which measures 136 degrees. So we just simply need to get their difference, and then we need to divide them by 2 to get the value of the angle x formed by the two secant segments outside the circle. But there is one thing that you need to understand when you take the difference of two numbers, especially with two measurements. You need to make sure that the longest arc should be written first. You have here 136 degrees before you subtract the shorter arc. This is done so that whatever the value on your difference, it will not give you negative measurement, because in this given example, the angle should be positive. This is also the reason why in other references, they use absolute value of the difference. So you have your absolute value of the difference, so that regardless of which arc or which measurement of arc is written first, and even if it's negative, we take its absolute value. So the other statement for this is the measurement of an angle formed by intersecting secants is half the absolute value of the intercepted arcs. That's another statement. But just for this, since we know the values, let's try to use this one. In short, the measurement of angle x is equal to 1/2 the value or the difference of 136 minus 58. The result is given to be 78 degrees. Right, let us check. Yes, that's 78 degrees. And then we divide it to the measurement of angle x is 1/2 78 degrees. So the result or the answer for the measurement of this angle here outside is 39 degrees. This is how we solve angle x. The next one that we could solve is angle y. In solving for angle y, we could always look into its relationship as the inscribed angle to its intercepted arc. However, we are only given with one arc, which is 58 degrees. This is still part of the intercepted arc that is intercepted by angle y, but we don't know its value. So how do we solve for y? Simply look into the triangle formed here by the 2 secant segments and this chord, which is a side of angle y. We have this angle x, which measures 39 degrees, the angle here, which measures 95 degrees, and angle y. According to triangle angle sum theorem, it should be given that the sum of the interior angles of any triangle is equal to 180 degrees. That would mean, let's move this up a little bit, we are going to add the measurement of the angles. So measurement of angle x plus 95 degrees plus measurement of angle y is equal to 180 degrees, as the triangle angle sum theorem tells us. Now, since we know already what's the measurement of angle x, we simply substitute here 39 degrees plus 95 degrees plus the measurement of angle y is equal to 180 degrees. Therefore, the measurement of angle y is equal to 180 degrees less the sum of the two angles, 39 degrees and 95 degrees. That's, if I'm correct, 134. So less 134 degrees, which will give you a result for the measurement of angle y equal to 46 degrees. Now that we are done with x, we're also done with y. Let's look into how do we solve z. Now, let me increase this a little bit here for some additional discussions. We know that z is an arc, and it's part of the intercepted arc of an angle which measures 95 degrees. Together with this arc here, they come up with one major arc. We know that this 95 degrees is called as the inscribed angle of circle C. Now let's look into its relationship. Because it's an inscribed angle, that said measurement must be half of its intercepted arc. The intercepted arc is not just 58 degrees, but it includes the z. So it should be 1/2 of the sum of 58 degrees and z. This is now the equation that can be used to solve the value of z. When we multiply both sides to cancel this fraction, you will get here a result of 190 degrees equal to 58 degrees plus the intended z. And then by using subtraction property of equality and the symmetric property, we will get here a result for z, which is the arc, which is equal to 190 degrees less 58 degrees, that's 58 degrees, which will give you a result equal to 132 degrees. This is the value of this arc z. If you're not convinced, let's try. 132 plus 58 is 190. And then this is our inscribed angle, so half of 190, 95 degrees. We are done with solving x, y, and z for this circle C.